asked to write the left-hand side in partial fractions, although we were given a big hint because it's told us basically how to write it. If you weren't given this on the right-hand side, you should realize that we can't just go with the normal thing like that because the denominator has the same or greater, well, same in this case, but if it's also greater power than the bottom, then you need this extra condition. One way to deal with it is to do a long division, and I will go through that method. But because they've given it in this way, let's just go with the sort of normal way that you would do it. Multiply through by that x minus 3, 1 minus 2x. So we will get a times x minus 3, 1 minus 2x, plus b, 1 minus 2x, plus c, x minus 3. And now we can, I mean, there's different ways to solve this, but I'll go with substituting in. That's always a good shout. So x equals 3 will give 1 plus 33 minus 6 times 3 squared, which actually is minus 20. And that will equal, so the a term disappears, the c term disappears. I'm going to get 1 minus 6 is minus 5. I'm going to get minus 5b here, so b is actually 4. Okay, one down. Next up, let's go with x is equal to a half, because then the first two terms will disappear. I'll do 1 plus 11 over 2 minus 6 times a half squared. I get 5. And then that will equal c times a half minus 3 over 2. That's actually minus 5 over 2. So c is going to equal minus 2. And then to get a, one way would be to go with 0. That's quite a nice strategy. So we get 1 is going to equal minus 3a plus b, and then minus 3c. And sub in the values that we know. So 1 is going to equal minus 3a plus 4 plus 6. That means minus 3a is going to equal minus 9. A is going to be 3. Another way we could have done it would be to compare coefficients. Actually, I'd say this is the best method. I can look at the coefficient of x squared. So on the left-hand side, I have minus 6. And on the right-hand side, actually, I just have minus 2 a x squared. So minus 6 must equal minus 2a, and a is 3 that way. Actually, much quicker. Really, don't rule that one out for a bit of speed. But anyway, that's our answer, a equals 3. I'm just going to write out, I mean, we are actually done for the question, but I'm just going to then write out the final answer in terms of the fractions. So 3 plus 4 over x minus 3 minus 2 over 1 minus 2x. So just before I do part B, I'm going to show you an alternative way of doing A. We could write it as 1 plus 11x minus 6x squared and multiply out the bottom, giving me, well, it's a bit awkward, but minus 2x squared. And I've got minus plus 6x plus x, so it's going to be plus 7x minus 3. And then I can do a polynomial division of that. But write it so it's minus x squared first, plus 11x, basically reverse the order. Then minus 2x squared into minus 6x squared goes 3. Actually, hey, that's our a, sorted. Multiply back through. Subtract. I get minus 10x plus 10. So what I've actually just shown is that this thing on the left is going to be 3, because that's my quotient. And then I'll have plus minus 10x plus 10 that I still need to divide by this thing here, which I might as well now factorize again. And then you can use partial fractions on this one. Do you know what? I think I'm going to do that. So minus 10x plus 10 all over x minus 3. So this is back to case 1 of partial fractions, distinct roots. We're just going to get a. I mean, this is a different a now. That's all I've got to be careful about. So actually, let me change it because it's really going to be, it's going to be b over x minus 3. That's then the same b plus c over 1 minus 2x. Multiply through. So if you weren't given the starting right-hand side, I'd say this is the way to go because you wouldn't necessarily see that you can write it like that. So do the division, then we get to kind of this kind of partial fraction. So now just the same as before, x is equal to 3. It's going to give minus 30. Wait, minus 30 plus 10, which will give minus 20, which is equal to minus 5b. And again, we get b is 4. X is a half, gives minus 5 plus 10, so 5 is equal to minus 5 over 2c, so c is again minus 2. We've got exactly the same answer. Of course, we have to, just with a slightly different method. Now on to the next part. F of x is the function we had at the beginning. X is greater than 3. Prove that we get a decreasing function. So what we can do straight away is write our function as we found it at the end. And then let's differentiate. I should also, sorry, I should first of all just write it as powers, I think. So 3 plus 4, x minus 3 to the minus 1, minus 2, 1 minus 2x, all to the minus 1. Then when I differentiate, I will bring the power down, so I'll get minus 4, x minus 3 to the minus 2. Nothing, when I differentiate the inside, I just get 1, so I don't need to do anything else with that. And then over here, I'll get minus 2 times, then I'll bring the minus 1 down and make it 1 minus 2x to the minus 2. But then I also need to times by the derivative of the inside, which is minus 2. I've actually got 3 negatives here. So I'll get minus 4 over x minus 3 squared minus 4 over 1 minus 2x all squared, which I can write as this here. Okay, bring the minus out. So I'm basically adding two things together. And then I'm making it, that's going to be positive, by the way. And then I'm making it negative. So terms inside brackets are both positive. Therefore, df by dx will be less than 0 for all x. I'll say greater than 3. So f is decreasing. Is that what it asked for? Is a decreasing function. So slightly different application of partial fractions there. We quite often use it to integrate, but it works out nicely to differentiate here. Whereas if you differentiated the original one, it would just be, you could, of course, do that. In theory, you could differentiate that and use the quotient rule. It's just going to be a lot more complicated, and yeah, you'd have to cancel a lot of things out. So putting it in partial fractions really helps us out.